In this section, we're learning how to graph quadratic functions. Quadratic function has the form f of x equal ax squared plus bx plus c, with a is a non-zero number. For linear function, it has this format f of x ax plus b. For quadratic, we have to have the x squared term. So for linear function, it's a line. The function is a line. For quadratic function, the function shape is called a parabola. So this is graph of f of x equal x squared. It's the simplest form of the quadratic function. So it's just one term, x squared. And the coefficient is just 1. So the vertex is 0, 0. The domain is from -infinity to infinity, and the range is from 0 to infinity. Quadratic function can be written in this format as well: a times x minus h quantity squared plus k. So this format would allow us to use the graphing techniques to transform the graph of f of x squared. For example, the plus k would be a vertical shift. So if k is positive, then it moves up k unit, and if k is negative, then it moves down k unit. And for the h, x minus h, so this is performed on the x, so the shift is horizontal. So horizontal is the opposite, right? So if it's minus a number, then we shift to the right by that unit, number of unit. And if it's x plus a number, then it shifts to the left. And a in front of the x squared term, so this a, if it's positive, then it opens up. So it would look something like this. If a is negative, then it opens down. And if absolute value of a is greater than 1, then it's a stretch. And if it's less, between 0 and 1, then it's a shrink. So we can convert the function into the form x minus h squared plus k by completing the square. So here, by completing the square, first we use the first two terms. So keep the constant term by itself for now. So f of x squared minus 6x. Completing the square, we have to look at the number in front of x. So minus 6, take half of that. So that would be minus 3, and then square it. So we get 9. So we add 9 to the function. So to compensate that, we have to subtract 9 as well, so that we're not changing the value of the function. So we add 9, we minus 9. So the first part here, that's become x squared minus 2 times 3 times x plus 3 squared. So this is minus 2, minus 9 plus 7 is minus 2. And this part is a complete square, so that's x minus 3 squared and minus 2. So now we have, this is in the format of x minus h squared plus k. In this case, a is actually 1. So now we have this function f of x. So we can plot this, right? So if x squared looks something like this, then this is minus 3, so that's shift to the right 3 unit. And then minus 2, that means it vertically down 2 units. So this will be f of x minus 3 squared minus 2. In this example, f of x is x squared minus 10x plus 21. So keep the 21 on the side for now, and preparing to complete the square using the first two terms. So take half of negative 10, which is negative 5. Square of that is 25. So we add 25. So we have to subtract 25 to balance it. So this becomes negative 4, and this is a complete square. So that's x minus 5 squared minus 4. So we could graph this by shifting the graph of x squared by shift to the right 5 units and shift down 4 units. We can also convert the function into this format by using a formula. So we can find h by calculating minus b over 2a, negative b over 2a, and to find k, we can just do function of h. So this process doesn't require completing the square at all. So just calculate h and then find k by plug in the value of h into the function. That would be k. So let's try this. 2x squared plus 4x plus 5. So a is 2, b is 4, and c is 5. So h is minus b over 2a is 4 over 2 times 2. So this is negative 4 over 4, which is negative 1. And k is f of h. So that's f of negative 1. So f of negative 1, we can plug in 2 times negative 1 squared plus 4 times negative 1 plus 5. So that's 2 minus 4 plus 5. So that's 3. And so f of x is a times x minus h squared plus k, then would be 2 times x minus 1 squared plus 3. So that's 2 times x plus 1 squared plus 3. So this means that we shift to the left 1 unit and shift up 3 units. One unit to the left and 3 units. So the vertex is at negative 1, 3. And the axis of symmetry is the line x equal to negative 1. So in the example, we found h to be 5 and f of h is negative 4. So f of x then is x minus 5 squared minus 4. So we shift to the right 5 units and shift down 4 units. So the vertex is 5, negative 4, and the axis of symmetry is the line x equal 5.